Okay, here we go. I'm going to give you the full class here. This class requires you to use a protractor. Um, I typically will hand out a sheet to people when we do this. I just ask that you practice it at home. Here's the homework. All right, so this class is our introduction into angles, or the first official class we get on angles. Angles are roughly, and I'll say this a few times during this presentation, angles are roughly 50% of all the questions asked in a geometry textbook. How big is an angle? So it's an important intro class. All right, so let's explain first what an angle is. An angle starts with not one ray, but it starts actually with two rays. And if you take two rays and you push them together so that their endpoints overlap, just like that, you get an angle. And which is why the definition of an angle is a figure or shape formed by two rays that share a common endpoint. And that's what an angle is. If that didn't really sink in, rewind, play that again. All right, with all shapes in geometry, we start with the shape, we define the shape, and then we state how to name the angle. There are four different ways to name an angle. This is slightly confusing at first. You'll get the hang of it pretty quickly. All right, so way number one to name an angle is we don't start at the vertex, at the V. Imagine this angle is V-shaped, and letter B right there is what's called the vertex. We're not going to start with B. We're going to start with either A or C. And then the only rule is that you must stay on the black line or the black ray right there. So if we start with A and we stay on the black, it goes ABC. If we start with C, it goes CBA. And then lastly, we need a symbol for an angle, and the symbol for an angle is an angle. So that is angle ABC. That's what defines the angle. Remember, there's an infinite number of points that make up that shape, but I just need three letters to define that. I need one point on the ray and its endpoint for each ray, and that would give you ABC. Notice that B, the vertex, is in the middle of those three letters. It could also be called CBA. That's the second way. There's two ways left. This one's a little bit harder to understand at first, but you'll get the hang of it very quickly. If the angle is all by itself, like this angle, there's no other shape there but that angle, then you can absolutely call it by its vertex, or angle B. And so you might be thinking to yourself, that's way easier than saying ABC or CBA, and I'll explain why you can't always do that in the next slide. So way number three to name an angle is naming it by its vertex. And lastly, sometimes the picture gets very cluttered. I'll show you an example here in a second. When the picture gets very cluttered, occasionally there will be a number at the vertex. You see that number that I just made right there, one? Notice it doesn't have a degree symbol, so that's not a 1 degree angle. That's actually its name. So we could also call this angle angle one. I would highly recommend replay that part of the video. All right, so I promised I would show you why we can't always call an angle by its vertex. Take a look at this shape and ask yourself, how many actual angles are there? There's a lot of them. If I want to name this green angle, this one right here, and I say that's angle E, well, somebody might be thinking, if I call that angle E, somebody might be thinking it's that angle. Or maybe E is that angle or that angle. Notice there's lots of angles that could be defined by the vertex of angle E. So when the picture is complicated like this, we have more than one angle attached to a vertex, you cannot, I'll say that again, you cannot name it by its vertex. So we would need to call this one angle CED or DEC. Hope that makes sense. I also promise you, why would we name it by numbers? Notice how cluttered this picture is here with the points. If we put numbers, it's a little bit easier to read. So that angle right there is angle 2. You'll see this frequently in our book. If you want to flip through the book and look through it, you'll see this done. All right, so the first thing, pause the video. I want you to name this angle four different ways. Okay, so this is either angle DEF or angle FED or angle E. We can call it angle E because the angle is there all by itself. It doesn't look like the previous. I'm going to go back. It doesn't look like that. The angle is sitting here all by itself. So we can't call it angle E, or we can call it angle 4. Got it? All right. In high school geometry, the pictures are complicated. Notice there's lots of stuff going on in that one shape. or even this shape right here. Lots of stuff going on in this shape. So notice this particular picture names the angles by numbers, and then we could also name the angle by letters. So for instance, if I look right here for that angle, that is either angle A. Notice I can call that one angle A, or it's angle 1, or it's angle DAB, or angle BAD. And, well, this E over here, we could also call angle 1. We could also call it EAB or BAE. That's a lot of options. That's a lot of options. Okay. Um, our book doesn't do it, but in case you ever run into it, not only can you use numbers, you can use lowercase letters to designate angles as well too. Our book will never have this, but just in case you run into it. All right, so now we can name angles four different ways. We briefly talked about the vertex. The vertex is here, where the two rays come together. They share that common endpoint. And then the definition of the vertex is as follows. It's the point of intersection of the two sides of an angle, or where the two rays come together at their endpoints. If you can imagine a triangle, right? A triangle has three angles. That's why it's called three angles, triangle. And a triangle has three vertexes, except we don't say vertexes, we say vertices. So the plural of vertex is vertices. All right, so it turns out that we measure angles with protractors. This is the part of the class where, since you're not there in class, we would get protractors and we would measure a bunch of angles. And I'm going to skip this portion. If you need, there is no time in our book where it gives you angles that you have to measure with angles or with a protractor. It might say use a protractor, very occasionally, 4 or 5 times tops. It might say use a protractor to construct an angle. So if you need to have a class on how to use a protractor, come see me. I can give you it's about a 2-minute instruction, and I'll help you with that. It works better in class, not on a video. Sometimes when using a protractor, it's really hard to put the protractor up to this angle because notice the legs of the rays aren't very long. You can always use a straight edge to extend a leg to help you use your protractor. All right, if you were in class, I'd have you measure these four angles. We're not going to do that right here. If you want to put a protractor up to your screen, it may or may not give you these numbers because whenever it projects on a screen, it can slightly change the perspective. But roughly, you can see that those are the angles. All right. All right. For the rest of the class, this is the key. All right. You guys know what irony is? Fire department burning up, that would be irony. 50% of all the questions asked in your geometry book simply say, how big is an angle? And the irony there is that 99.9% of the time, they don't want you to use a protractor. They want you to use the given information and some logic. And that is one of the hardest things to learn in geometry, or the hardest things to handle is, once again, it's not like there's steps involved. You have to look at a picture. You have to use all of your knowledge about the shapes that you see to get to how big of an angle is. When you actually do some for homework, this statement I just made will make sense. All right. So we're not going to use a protractor unless it says to use a protractor. And like I said, I can't think of a single question where it says use a protractor to measure an angle, but it might say use a protractor to draw an angle. And even that is only done very sparingly. All right. Yes, we get a little ridiculous here. Remember, we got ridiculous last time when we had the name of a segment, and when we measured a segment, we took the little segment off the top of it when we stated its measure. We do the same thing with angles. So if we measure an angle and we want its name, the name of that angle is angle B, right? But if we want to say how big that angle is, and for whatever, we either use a protractor or some logic, we figured out, we put a little M in front of that symbol. So M stands for the measure. So the measure of angle B, then you put an equal sign, the degree measurement, and the degree symbol. The degree symbol is in the upper right, and it's a little tiny circle. You've seen it before. Also recall that this is not something new for you. You learned this in pre-algebra, that we classify angles by 4 different ways, and hopefully you're yelling at the screen right now those names. So we'll start off with the smallest type of angle. This is an angle that's greater than 0 degrees. If it's 0 degrees, it's not an angle. But if it's bigger than 0 degrees, but less than 90, notice that's what it says there in yellow, bigger than zero, but less than 90, we call it an acute angle. I'll do this very quickly. You can always pause the video and write this down. Now, if you were exactly 90 degrees, hopefully you know this, you are called a right angle. And we have a symbol because right angles are special. We like them. You can look around your room right now and see a whole lot of right angles. And we indicate if an angle is right by putting a square at the vertex. Can you see that? That's what the arrow is pointing to. That's a right angle. If there is no square, it still could be 90 degrees. But if there is a square, we're stating definitively that it's 90 degrees. All right, so is this one a right angle? Maybe, it could be if you measure it and it's 90 degrees. But is this one a 90-degree angle? Now notice I deliberately made the angle not look like 9 degrees. But if there's a square there, that's a statement that it is definitely 9 degrees. And usually what happens is when someone's freehanding an angle and they don't make it look exactly like 90, but they put a square there, it is 100% 9 degrees. If that didn't make sense, rewind and play that again. All right, so classifying angles. Let's see. If you're bigger than 90, but you're less than 180, right? Bigger than 90, but less than 180, you are obtuse. Notice that's a book definition right there. Me personally, I would like if they had said an angle greater than 90, but less than 180. And the last one, the one that everyone forgets, is if we have a straight line, we put a protractor on it, it measures 180 degrees exactly. So we call this a straight angle. Believe it or not, this angle right here, the angle measurement of a ray, a line, or a segment, is used quite often. In fact, tonight for homework, there's going to be multiple questions that you need to use the fact that a straight line, ray, or segment has an angle measurement of 180 degrees to get to an answer. You'll see when you do the homework. Okay. Let's see. By observation. Let's measure these angles, or let's classify these angles by their angle type. Upper left is an acute. Lower right is also acute. Upper right. I said lower right. I meant upper left, lower left. There we go. Upper right is obtuse, and the lower right one. It's not drawn perfectly. I meant to draw it 90 degrees. If it looks like it's 90, great, but some people say it looks more obtuse. I get that. I would never give you a test where it would be that close to being right or obtuse or acute. You know, it would be very clear. If it has a little square, you're going to put right. If it doesn't have a square, I'm not going to put an angle that looks like that and ask you, oh no, that one actually is obtuse, no, or it's right. I'll make it nice and clear. Another note, this is not in a book, but I'm gonna give it to you. Notice the angle right there, the angle measurement right there. Well, a smart kid would point out, well, what if you went on the other direction? In other words, outside of the angle all the way around. Well, that is also an angle. It has a name. We call it a reflex angle, and that's an angle that's greater than 180 but less than 360. So you'd figure that if you knew the red angle right there, subtract the red measurement from 360, and that's how big the blue angle would be right there. I only point that out because occasionally you might see that this year when you take the PSAT test, you might see a reflex angle. Our book never covers it though, so here we go. I'm covering it right now. All right. Remember we talked about previously postulates, theorems, and corollaries. Postulates we just accept as being true without proof. Theorems we will prove. That's what we start doing next chapter, learning how to prove things. And then corollaries come from theorems. They're also things that we'll prove, but they come from another theorem. So we're going to write down a couple postulates now. So this is postulate number 3. Remember we did postulate number 1, we talked about the ruler postulate. Well, postulate number 3 basically is the same thing except for angles. And it states that if you have a straight line or array or segment and a point between 2 points, so O is between A and B, you can create the degrees all the way up to 180 just by making them separated evenly. And that's what that statement there. I don't want you to actually write this point. I want you to read it. but I don't want you to write this one down. There's a second part of this postulate, the one that's the more important one. Okay, recall that the ruler postulate had a second part. Part one, number one, was just like the previous one, where it said a ruler can be created. But part number two stated that if you want to figure out the distance between B and D, you put your ruler up to it, you look at um, 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 the points values. Underneath B is 1, underneath D is 3, and you take the absolute value of those two numbers subtracted. So if we go from D to B, we subtract 1 from 3, or 3 minus 1, take the absolute value. Or if we go from B to D, it's the same distance. 1 minus 3 is -2, we take the absolute value. Remember doing that? Okay. And so we do the same thing with the protractor. So this is the part two, the part we're going to write down here in a second. So if you have an angle, right? So let's say we have angle AOD. See angle AOD, right? And we'll say that one is 130 degrees. If I take that 130 degrees and break it up into, I'm not breaking it up necessarily into equal parts, but if I break it up into two more angles, I've created two more angles here. I've created AOC and COD. And if I measure one of those and I find out that it's 50, the question is, how big is COD? And just like for the ruler postulate, we use subtraction to get the answer. We're going to do the same thing here. If you want to find that third angle, then you subtract the two angle measurements and take the absolute value. So you do 130 minus 50 to find COD. That would be 80. Or you do 50 minus 130. That would be -80 degrees. But then you take the absolute value and you get 80 degrees. You might want to play that one again to make sure that sinks in. There's going to be a couple questions tonight for homework where it looks like this, and they'll say, how big is an angle? And they'll give you two of the angles. You're figuring out the third one. You figure it out using subtraction. All right, so this is the part I want you to write down, the second part. The angular distance between any two rays. So the angular distance of COD between any two rays, notice those rays there, right? Will be the absolute value of the difference of their angle measurements. I'm going back one more time. So 130 and 50. So we take the absolute value of their differences. 130 minus 50 is 80. All right, so that's postulate number three. We now have three postulates in our book of truth. We have a bunch of definitions and postulates. Do you remember postulate two right after the ruler postulate? Postulate number two is the one that we stated that the small piece plus the medium piece equals the whole piece. We call it the segment addition postulate. We get the same thing with angles. It's called the angle addition postulate. And the angle addition postulate says it basically the same thing as the segment addition postulate. If you want to know the larger angle there, COA, if you want to know the larger angle, COA, it's the sum of the two smaller angles. In other words, the smallest angle there, AOB, plus angle COB would equal the larger angle, AOC. Pause the video, look at that, and remember the word small plus medium equals the whole thing. Okay. So how do you use this? It's pretty straightforward. Notice they're giving us two of the three angles. We plug in the information. The small piece, which would be AOB, is undefined, so it is X. Plus the medium angle there is COB, which is 95. Well, that must equal the entire angle, which is COA. COA is 125. And just like with the segment addition postulate, you do a little bit of algebra to get to the answer. I subtracted 95 from both sides. Okay. Notice that X is equal to 30, but how big is the angle? We put the little degree symbol right there. All right. Quick definition. What would happen if I had this construction and COB was 75 degrees and AOB was 75 degrees? That would mean that those two angles are the same. 75 equals 75. If two angles are the same, those aren't the same angles. One is COB, one is AOB, so they're not literally the physically same angle, but they have the same measurements. Remember, that's the concept in geometry of congruency. When you have two shapes that are the same and they have equal measures, remember, it's two different shapes in the sense of unique shapes, then we can call these congruent angles. These are angles that have equal measure. 75 equals 75. And remember, we have a symbol for congruency. That's that equal sign with the tilde above it. So we could say AOB is congruent to angle COB. And the one consequence from congruence is that their measurements are equal. Now remember, for angles, if I talk about their measurement, I put that little M there. Make sense? Okay. Um, Remember for segments, if two segments have the same measurement, we can put little tick marks. Well, we can't put a tick mark for an angle, so we put arcs for angles if they're congruent or have equal measures. So notice right there, since both angles are 75, they're equal to each other. I indicate that if I don't want to write the numbers with arcs. One arc angle is equal to another angle that has one arc. If I were to put two arcs on COB, then it would only be equal to another angle that had two arcs. We'll see that, just we won't see it today, but we'll see it as we move into the book. They'll use one arc, two arc, and sometimes even three arcs. It gets very messy. You've got to use four arcs. So those two angles are equal because the two angles are congruent. All right, a few more definitions and we're done. All right, so let's think about this. Notice the shape right there. We have two basic angles right there. Third counting the larger angle. But look at those two angles that I just highlighted. That angle right there and that angle right there. Notice that they share two things. Both of those angles share the vertex C and they share the ray CD. If that's the case, if two angles share a vertex and a common side, we say that they are adjacent angles. So adjacent angles are angles that share a vertex and a side, but no interior points. I'll try to roughly draw what that means, right? If you had one angle right here and another angle right here, as opposed to one angle right here, and then I'm going to draw this one in red, and the second angle looks like this. Notice now they're in this area right here. In both angles, they share points. In both angles, they share points. So I like to say if two angles overlap, they're not adjacent. For two angles to be adjacent, they must share a vertex and a common side. Hopefully that makes sense. If not, ask me when the next time that I see you about, or give me a better explanation of adjacent angles. Okay, so we could say that ACD is adjacent to angle DCB. Makes sense? Good. Okay, common side, common vertex. In class, I would have asked, hey, name two adjacent angles. Hopefully you could do that. So let's see. Angle FEG is adjacent to angle GEH, right? Or HEG. Those are adjacent angles. Further, all right, last definition. If you have a ray that cuts a larger angle in half. Notice this ray, OB, cut angle COA in half. I created two equal angles. We call that ray, since it cut the larger angle in half, we call it a bisector. So the bisector of an angle is a ray, that's ray OB, that divides an angle into two congruent angles. And you could further say it makes two adjacent angles. COB is adjacent to BOA. That makes sense? Good, because that's the end of the class. That was that shape I just showed you. So we were starting off with complicated ones. As you're doing your homework, I want you to remember, keep this in the back of your mind, that if you have a straight line, you have 180 degrees. If you have a straight line, you have 180 degrees. I think that's questions 32 and 34 require you to use that in order to make up an equation. All right, here's your homework. If you have any questions, see me the next time you see me and ask the questions. If not, have a wonderful day or evening.